Hello, my name is Jennifer Susana Reina and I'm the leader of this project, which is a Pulper machine. Before we begin with the video, I would like to mention the people involved in this project. First, we have the design team conformed by Humberto Escobedo and Janine Nevares. Then we have the manufacturing team conformed by Javier Hernandez and Juan Carlos Martinez. And finally, the automation team conformed by Oscar Alonso Gomez and me. During this video, we want to talk about how the idea came to our mind, why do we select the project, the initial research that we made, and also how do we work in the project during these 4 months. I hope you enjoyed, and let's begin. Well, before we begin with the project, there are some points that I would like to mention. The first one is to explain what is a pulper machine. Basically, a pulper machine is an instrument used to improve the production time of the pulping process. And what does the pulping process involve? In a few words, is to take off the seeds and the shell of the fruit to obtain the pulp, which is used to make products like juices, additives, and jams. And this process begins with the fruit is peeled, then cut into smaller pieces if it's needed. Then the fruit is grained until we obtain a kind of paste. And finally, this paste is filtered to avoid seeds or pieces of shell in the pulp. Assuming we want to process between 1.5 to 2 kilograms, the manual process takes between 50 to 80 minutes, and it requires 2 to 3 people. The third point I would like to talk about is that there are different types of pulping machine. They are mostly classified according to the production rate that is needed. We have low, medium, and high production. An example of a low production rate could be a juice stand, where people process only the fruit they are going to need according to the number of customers. On the other hand, we have the high production rate where we can find enterprises like Jumex or Del Valle that produce a large amount of products per day. Now, talking about our project, we are focused on the medium production rate. And at first moment, this was because one of our colleagues required the machine for a small business he has. But after we researched, we found out that it was the most common one type of production rate, not only here in Mexico, but also in other South American countries. So we found it as a good opportunity. Okay, the main objective of this project, of course, is to apply our knowledge, but talking more about the social focus of the project, as I said, we are focused on the medium production rate, which include small businesses. We want to help these small businesses to grow. We want them to make their own way in the market. We want them to be able to compete with other enterprises. And we also want to motivate people to begin their own business.
I'm going to explain you a few of the points of this design. Well, we took the idea from some other models on the internet. We are using a 17-degree inclination on the machine, so gravity can push the fruit way down without using any other mechanism or attachment. All the body of the machine is made out of stainless steel because we are working directly with food. Just the pulleys and the bearings are of aluminum and cast iron, respectively. The main body has a cylindrical shape, so we can have a uniform surface inside and the blades won't collide with anything but the fruit. The piece that contains the shell of the fruit is a cylinder with many holes all along the body and around the circumference, and in this part of the machine the fruit flows at the same time is crushed, so we can separate the shell and the fruit. The cover of a bowl is removable for cleaning labors as well as maintenance, and when the machine is working it prevents pieces of fruit going out of the machine. For the mechanism, we decided to use two pulleys made of aluminum. The most important reason of why we use this mechanism is the distance between the engine and the shaft. It's also easy to change belts and lubricate them, and the replacements are cheaper than chains. The driver pulley is of 36 millimeters of diameter. and the drive end is of 197 millimeters of diameter. Through some equations we could found some factors of functioning of this transmission mechanism. The first thing we calculated was the length of the belt, given by the next equation. We already knew some data, so by substituting values, we got that the belt needs to be around 1070.285 millimeters. And with the length of the belt, we obtained that the pitch diameter is of 3269.54 millimeters. We know that the angles of contact are important because thanks to them we can know how much force are we wasting or how much we are overforcing the machine. And in this case, for our transmission, for the driver belt, we have an angle of 152 degrees, which is not the best, but is higher than 120 degrees. That is the minimum. And for the drive end, we got an angle of 207 degrees, which is higher than 180, but is still acceptable. Finally, for the velocity radio, we got one of 0.182 by dividing radius 1 between radius 2, and for the belt speed we got a result of 3.204 meters per second.
And today I'm going to start explaining to all of you our transmission, some of its advantages, and why we chose it. So first of all, it consists of a belt drive with pulleys. Its main function or its main purpose is to transmit rotational motion from one shaft to another. And we chose it because it is cheap, it produces less noise than other transmissions or other mechanisms, even if it is working at high speeds. It requires low maintenance and also does not need any lubrication, and it is easy to install. And the belt, we chose it with the V structure because this specific shape causes the belt to wedge tightly into the pulley, and this increases the friction and hence the torque. And the torque is very important to us in this project because it is fixed into the main mechanism, or the one that we consider the most important one, which is the axis, because it is the responsible for the whole process. So in order to state it before, this specific transmission increases the torque. So we have an initial torque, which is the one given by the motor, and then the final or resultant torque. And we had to calculate this one. So the initial torque was of 3.95 newtons per meter, and the resultant one was of 21.65 newtons per meter. And as you can see, it's way bigger than the initial torque. And why is it important? Because knowing this value of the final torque, we were able to make the torsion analysis, and we were also able to calculate the shear stress and the safety factor of the material. In this part, we have the static analysis of the axis or the torsion analysis, and here in this part we added the 21.75 newtons per meter, which is the torque, and we obtained a maximum shear stress of 90.8 megapascals. And our resultant safety factor is of 4.24, which means that this shaft, or in this case this axis, can handle or can support 4.2 times the load that we are applying to it. And here, as you can see, it's of 4.2, but here is an example of a safety factor of 5, which is the case in case that we overpass that value, we can see that it starts to deform or to break in this part. But if we just adjust it at 2, which is the one that we chose, in order to keep in good shape our machine, we can see now that it is completely fine and nothing happens to the shaft.
Today I will talk about the manufacture part of the pulper machine. First of all, we're going to talk about the material and the welding process. We decided to use stainless steel since the machine will be working with feet. Therefore, this material was the perfect choice. In a wide variety of stainless steels, we had three options: the 430, the 304, and the 316. The 304 is characterized by its resistance to corrosion, and compared to the 430, it has way more resistance. Talking about the price, the 304 is not as expensive as the 316, whereby the 304 was the picked one. Regarding the welding process, we used the MIG process with shielding gas where a wire electrode was used, and according to the American Welding Society, the ER309 LSI wire electrode is the suitable when welding 304 stainless steel. And the shielding gases that were used are argon and carbon dioxide. Now let's talk about the CNC machining. This piece is the one that was mechanized by the CNC milling machine, considering that this part requires more accuracy than others. At the beginning we had a problem with the size of the piece, but we made some corrections and we could make it smaller. Now let's see how the simulation is made. As we can see here in the simulation, the piece was first roughed down with a pocket operation, and then after the rough down was made, a countermill operation was made. This in order to remove more material in the edges of the piece. So as we can see, then the contour is made, and the piece was roughed down again twice. We can see that's the first one, and there you have the second one. And then finally, in order to release the piece, a buzz was made.
I'm going to talk about the machining process used in the manufacture of our machine. These processes are drilling and turning. The drilling process is used to fix the different parts using screws and nuts. For example, in this part and these parts. The turning process is used to allow the shaft to pass through the bearings and pulleys. Almost 100% of the structural and manufactured mobile parts are made of stainless steel. Only two pieces of rubber are used in the blade. These are the examples, here and here. Machine design allows an easy access to bolts and nuts for easy disassembly and assembly in case maintenance is required.
To talk about the automation of our project. First of all, I'm going to talk about the type of controller that we decided to use for our project. In this occasion, we decided to use the microcontroller at Mega 328P, which can be found in the Arduino development board. This microcontroller can work with 5 volts, that is perfect for our project as we are using LCDs that work with set voltage and all the other type of sensor that we're using in this same project. This is beneficial for us because we can use a single power supply to give power to the whole electronics without having the need of multiple voltages for the controller. It also has an I2C communication protocol that we're using in this case to control the I2C controller for the LCD, and also has 6 analog pins that are more than enough, and we only require one extra pin of these ones for a potentiometer to set a time for the timer function that we implemented in our project. Some advantages of this microcontroller, this specific microcontroller, than other ones. Some of these one is the no additional programmer burner and hardware required for programming. It has a low power consumption that other controllers such as PLC. It also has a simplified and user-friendly programming language with a large library documentation that it makes easier to work with communications or external sensors like the LCD, and it also comes in an easy to manage package that is the true whole technology.
Now I'm going to talk about the sensors and actuators of this system. First, we have the sensors, where we include 3 buttons: one to turn the machine on, one to turn it off, and the emergency stop button. Then we include a limit switch for the door and a fruit sensor that are part of the security elements of the machine. We also have another switch that is going to be in charge of turning on and off a timer function that we decide to include to the machine, and the potentiometer that is going to be in charge of the timer function. Then in actuators we have the motor that is the main actuator of the system, and we also include a LCD screen where the reminding time of the timer function will be shown, or if there is an error, for example if the door is not closed, or other kind of errors that the machine could detect. And in others we have the relays that are going to be in charge of turning on and off the motor. All of this, or most of them, are located in a control pad that is going to be in one of the sides of the machine. And as you can see, is like really basic. We have the 3 buttons and the switch. We also decide to include LEDs in order to let the operator know if the machine is function, if the machine is off, or if there is an error that he or she needs to check.
Now the security elements. The first security element is an emergency stop button that is used to cut off the power supply for the whole machine so that nothing can stop it from stopping the machine. Is used in case of any strange sound object detected inside the machine. The second security element that we have is a door sensor that is going to be a limit switch. This sensor is going to tell us if the door is open or closed, and it won't let the machine work if the door is open. This is because we don't want the product to be contaminated by the outside factors such as dust. So it requires the door to be closed and also to not expose any kind of moving part to the users. Then we also they have the fruit sensor that is not only going to be used for the timer function that we implemented, but also to prevent problems such as human limbs or unwanted objects being vulnerable to the machine blade.
Now, talking about how the machine will improve the pulping process, or basically how will the machine work. The first part of the process, of course, is to have the fruit we want to process. Once we have the fruit, we have to introduce it into this square shaped part. And when we introduce the whole fruit, the blade will begin to rotate, making the fruit collide or crash one with other, and also with the cylinder, until we have this kind of paste that I mentioned previously. What will happen with the shell and the seeds is that for gravity, since it is inclinated, they will begin to go down and they will go out through other hole or that the machine has, and the pulp will begin to go out through the holes of the perfect cylinder. And at the bottom of the machine, there will be a container where it will be collected. And this is basically how it works. Assuming we want to process the same 1.5, 2 kilograms of the manual process, will take between 20 to 30 minutes and it will require 1 to 2 people. Production cost of 40,110 pesos and a selling price is around 32,450 pesos. And this could be like a lot of money, but actually it's really cheap because one machine similar to ours has a cost of 80,000 pesos. So it's like almost half price. So it's a really good.